Okay, question 7. This one is on page 24 of our note package here. It talks about this information pertains to the next two questions here. Now this question's a little tougher. It kind of makes you or gets you to make a little bit of a leap from some of the stuff that we've been talking about a bit, because they're not giving you a lot of information on the particular legend or the genotypes and that. So there is a bit of a leap of faith here in this question for sure. So it says a plant breeder was trying to breed true breeding a variety of radishes that are oval shape. Okay. However, each time plants with oval radishes were self-fertilized, only half of them were actually oval, right? Some of them, or some of the rest of the plants, were producing either round or long radishes. Okay, so a bit of a tough question. So I find this better or easier if you actually draw out some of the phenotypes, and then let's see based on that information if we can come up with the correct legend. So what they're saying here is if I have, there's round radishes, some of them are round, okay? Some of them were really long radishes, but what they were hoping for were these oval guys, which is kind of a blending of those two. So this was oval, this was long, and this is round. So it, to me, looks like that oval is a blending of the round and the long alleles. And when we know that blending, we recognize that intermediate inheritance. So when they had just ovals and they tried to breed them, they were getting some of these round and long long radishes as well. So let's just make up a legend here. If we say capital R with a for radish, with a capital R and another one with a R with a capital R, we're going to say that's round. For long, we're going to say capital R for radish, but if I have an L and a homozygous situation, that's going to give me long. And oval is in between a round and a long, so I'm going to have both those alleles there. So capital R with an L, capital R with a R for round. That's going to be the intermediate. So it makes sense now that if I have two ovals, you can see that I will indeed get some round and long in those offspring as well. So you can never really get a pure oval, right? Pure meaning homozygous, both being the same, but you can't get that, and that's why when they tried to cross those oval parents, they were getting some oval, but they were also getting the round and long ones as well. So bit of a leap, I know, but that's kind of how you would utilize the steps in order to be able to solve that, right? Draw it out. That's the big strategy here. So once we know that legend, and that's our legend right here, let's go on to the questions. They're not so bad after that. That is by far the hardest part of these questions. What would be the expected phenotypic ratio if you took a long radish, underline that parent, and cross that with a long crossed with a round? So now that we have those legends up there, not so bad. Long is capital R, L, capital R, superscript L, crossed with a round radish, which is capital R, superscript R, capital R, superscript R. Bring those together. We can do the Punnett square, step 3. We don't know which one's male or female, so we're just going to arbitrarily put those across the top and down the side. And we can see what's going to happen here. We're going to get capital R, L, capital R, R. That's going to be a oval. Capital R, L, keep this consistent. Doesn't matter which one you put first, but just keep it consistent all the time. That's going to be an oval. Capital R, L, capital R, R. That's going to be oval. And they're all going to be the same. So 100% of these, 1 or 100% of these are going to be oval. And again, if they had this, how many were round? That would be 0. How many would be long? That would be 0 too. But 1 or 100% are going to be oval. So if we go to the next one here, what would be the expected F2 generation if you cross 2 of those first generation offspring? So all of those offspring of course, we said were capital R, L, capital R, R. So we're going to take two of those offspring, which are identical, and cross those guys to get an F2 generation. So Punnett square, capital R, L, capital R, R, capital R, L, capital R, R. Bring those guys together now, showing fertilization. That's going to be long. And this is exactly what they talked about in the first part of question 7a. Capital R, L, capital R, R. That's going to be oval. Capital R, R, capital R, R. That's going to be round. And capital R, L, capital R, R. That's going to be oval. Count up the boxes. Two of them are going to be oval. Ratio, one of them is going to be long. And one of these are going to be round. And there is our phenotypic ratio. Tough question, but that's probably as difficult as those intermediate or incomplete dominant questions are going to get. Okay, any issues, just give me an email. Thanks.